Yesterday, yesterday we have done the visualization and docking part, and today we will be seeing hydrogen bonds, and we will try to select some poses based on this information only. So let's start with hydrogen bond interaction analysis. So for that, we need to load our receptor and the resulted poses which from the file out.pdbqt. So for that I should open camera X. So in the last session I have opened ligout.pdbqt, which was in directory listed here directly. lig.out.pdbqt and receptor pdbqt, and results are stored in these files which we have saved from the command line. So now I will load these two files. Actually last time I have already opened this file in Chimera X, so I can directly load them one by one. So to load the first file, okay. So last time I used this receptor.pdbqt and lig.pdbqt, these two files. So I will load first this file, first receptor, this file, and then this file. To load two files without dragging and dropping means if you have already opened it, it will shown in the history files, and here for that first I will load the receptor pdbqt. So it will load receptor pdbqt file here, and then I can use this option, but bottom right corner here. Okay, so if I click this option, I will see again this window, and my model is already open here. My model is already open here, and I will see this window. If I click any other model which is already open, both the models will be shown open here. Okay, so I double actually I have opened this two times. Why cursor is disappeared? So I will click on ligand out.pdbqt, and from here I will close one older receptor file. Now you can see that there are two models loaded here, one receptor and another is ligand. So now I can perform the analysis part. To perform the analysis, here I will go to tools menu in Chimera X, and there I will use binding analysis option and use view docx. So for that I need to visit tools option here, tools option, binding analysis and view docs. So first this tool option menu, then binding option and view docx. After clicking this, tools, binding, view docx, it will automatically select ligand and PDBQT. Means it will select the receptor and ligand PDBQT as ligand. So it will give you one more window like this, from where you can see other analyze this. And here you will be seeing all of your docking poses. Like I have got 10 poses, and here I can see that 10 poses are listed. So I and all the poses are here. So to view the position of these poses, my cursor is not visible. Okay, so just to see the ligands ligand position, I can just hide the receptor and can see where are the all the ligands are here in are shown. So from here I can see the positions of ligand. And here since I double click on the view docx window, and it is docked here, I will double click and restore it. So from here I can see all the docking poses, and if I uncheck them, I can hide and show from this window as well. So from here I will check one by one. I am unhiding receptor again, and here I will check the first pose, location of the first pose, and it is appearing here. So it is binding somewhere in this condition. So like that, last time we have checked what is the site of binding of the binding of the ligand. So next is we need to find out the interactions, and there are multiple types of interactions we can understand from two entities. First one we can means there will be interactions between atoms. So in so first interaction type we try to find is hydrogen bonds. Means there should be involvement of hydrogen bonds, and among weak interactions, hydrogen bond is means abundant in biological system, and uh, regarded as the most stable conformation than other weaker forces. So first we will try to deduce find out hydrogen bond interactions, and then other types of interactions might be including salt bridges, where their coordinate coordinate bonds are formed, and pi interactions where some benzene ring like interactions occur, and other types of contacts like when two atoms come closer to each other, and come closer to each other and form some kind of covalent interactions. So based on these interactions, we will start our analysis part. So for first we will use hydrogen bonds for our study. And as we know that hydrogen bonds are formed between electronegative atom, formed between formed when hydrogen atom is present between two electronegative atoms. So for that condition, we will the software, or we will be checking that some electronegative atom is present, like there could be fluorine, oxygen or nitrogen, and that hydrogen is bonded to any of them, and then uh, another another group should be present where these electronegative atoms are present. So already bonded hydrogen atom group is known as donor, from where this hydrogen atom will be moved to electronegative higher electronegative atom, and it should not have it, so that it will be called as acceptor. And there will be some distance between these two groups, and that distance cutoff is based on already researches, and that may be ranging from some 2 Armstrong to roughly 2 Armstrong to 3 Armstrong. And when we are visualizing or analyzing from some software, they have different specific criteria, like they might be considering some plus minus, or plus minus means like error values we consider while our experiment. So there could be some range like 2.5 Armstrong to 3.5 Armstrong to characterize that this is a hydrogen bond. So in here we can get directly get direct option for hydrogen bond. So I will click on this add option, add H bond. So it what it will do, it will calculate hydrogen bonds between receptor and ligand, and add those hydrogen bonds. So for that I am just clicking on this add H bonds option here, and it will perform some calculations and show us the hydrogen bonds, and those hydrogen bonds will be listed here. Listed here means it has found some 9 hydrogen bonds, and for the criteria and other details we can simply go to this option, and where we will be getting more option and details about this result. Like what other options we can get along with hydrogen atoms, like for hydrogen atom calculation we can directly use this command as well, and also there and for other options, like I have already explained, that there is distance cutoff for calculation, so you can get that details in somewhere in the description. So, so basically it has a it will be showing us hydrogen bonds listed here, and those hydrogen bonds are colored as blue. So these hydrogen bonds are under this model ID 1, and the color of selected hydrogen bonds is painted as blue. So if I change this color as yellow or some other color, I'm changing this color to yellow for clear visualization. So you can see that a color is changing here. So this is one of the hydrogen bond formed here, and like that it has calculated hydrogen bonds for all the poses. So if we visualize all the poses, we can see all the hydrogen bonds. Finally, okay. So after clicking add hydrogen bonds, it has calculated all the hydrogen bonds and listed here. So if we want to know the number of hydrogen bonds it has calculated, then for the first pose means model ID 1, all the ligand are under model ID 3, and the poses predicted by Veena are numbered as 3.1, 3.2, so they are submodels, means demonstrated using dot 1. dot 1 here, and this one is hydrogen bond, number of hydrogen bonds in that structure with protein. So that all other poses have different number of hydrogen bonds, like here if you see 3.3 structure has not formed any hydrogen bond, and while the most number of hydrogen bonds are with 3.9. So means the energy of the stability of this pose should be better, because it is forming sort of better interactions. There are other things like classes, salt bridges, which we can calculate using Chimera X, but I will not focus today on that. We will restrict our study for the hydrogen bond only today, for today. And already we have gone through the scores, and one of the misconception is that if we select we if we are selecting best score as the best predicted drug interaction, then we may be wrong, because as we see here that at this score the hydrogen bond number of hydrogen bonds is more, and later on we will be seeing classes, other contacts, which might lead which might help us understand that other conformers could also be better. So I will be, focus on full protein here, and other poses are somewhere at different places. So how can I so I am going to select is my audio clearly visible to you? Is my audio audible to you people?
Yes, sir. Yes, sir.
Okay, actually there should be
No
some
issue.
background noise. Is there any background noise?
Yes, it was, sir.
Okay, okay,
Now it is okay.
okay. So here I am just going to if to select all these ligands, I will directly type SEL, and has 3 to select all the ligand structures. Here is the command SEL space has 3, sorry, has 3, and it will select all the ligands. So they are not clearly visible here. By that, after the selection I can change their uh, visualization like this, so they are clearly visible here. And yesterday I also told you about M series command, M series slider for model 3, uh, model 3, and what I forgot it, 3.1 to 10. Okay, maybe my command is I mistyped it. I will type it again, MSERIES. So I will repeat that command here. It is M series slider, and my model is 3.1 to 10, so I can cycle through the model IDs to visualize them one by one. I will close it for now, because we have already seen the hydrogen bonds and scores and added hydrogen bonds. There are plot and graph things, but we can directly see the number that there are 1 2 3, and sometimes these numbers are very higher. So for that we can use plot option as well, so that it tells us how many hydrogen bonds or other entities have been drawn here. I will close it for now, because we have already done with this option. And so I have got M series here, slider here, and if I click, if I up down these numbers, one models one by one will be shown. So just focus. you will be seeing changes here when I click this option. So, and also you will see movement of these ligand, means at different sites. So if I click on this, it will be moving like this. So I can visualize different positions or different binding sites of the ligand, like using this option. And if I play, it will just randomly switch through other ligand, other options. So like that I can visualize. And now we have seen that at position 9. So if I select 3.9, there are 3 hydrogen bonds, and we need to understand those hydrogen bonds. So after the selection, I will make it normal by hiding this surface and show it. And to focus on this ligand only, I will use command VIEW, view SEL. So it will view selected only, and it is selecting something else. Okay, what I will do, I will use cell 3.9, and it will select that option only, and view VEW SEL. So it is now showing me that ligand only. So now if I have selected these ligands, I to select all the related, means nearby atoms without selecting complete protein, I will use select option and zone option here. So when I come here, I select this option, I can select a criteria that what should be the range of the selection. So how it is going to work. Suppose this is my some entity or ligand. So and this is the complete protein. So if I tell it that it should select everything within the range of 0.5. So suppose this is some 3, 1, 2, 3. So this is some 3 Armstrong, and I want to select everything within the 0.5 range. So this will be something roughly some here, and from here it will try to select within the 0.5 Armstrong range. So like that it will select whatever comes in this area from this ligand point. So for that there is option zone select. To perform that, I have gone to select zone contacts, and then I got this option. I have chosen the criteria of 4, and here from here if I select atoms or residues, it will perform accordingly. But here I will use option residues, because I have ligand as one residue, and I want to select residues of the protein. So I will use residues option and select apply. So if you see clearly here, all the residues of the protein are selected now. So I can use action label option to label these residue, name and number, so that I can understand which residues are interacting with this particular ligand. So and also one thing that we have already differentially colored our hydrogen atoms, hydrogen bond. So that is shown here clearly. Fine. So this option is clear to you all, like that. And suppose that we find that this interaction should be reported, or we want to log this particular file, and means save as a image. So we can use image of file save option, and use jpg image, or directly we can copy paste the command. Actually I am emphasizing more on command line, because later on we can save all those command in a sequence for different receptor and ligand, and execute that directly for different multiple structures. So if I have thousands of structure, I need to just do some mathematics, and I can create one single file, and it will calculate all the things for all the files there. I will show that as well, but later on. So that's why you should learn how commands work. Now I want to save this. Yes, any question?
Yes, sir. Sir, your first ID, not first ID, is 3.1.
Yes,
The first structure. That has a maximum score. No, I think, sir, minus 7 point something
yes, it had maximum score. Yes,
score. So, like we are only targeting the maximum score, right, sir? Or
Y-
we can target any structure, like a different name is ID 3.1, 3.2, or
no,
confirmation different.
we are not. I'm confused. Let me first let us clear your question. You are asking that I means I have selected this current one single structure, right?
Ninth one, yes, sir.
Ninth
You
one. I have randomly selected it to make you understand how you can visualize things. Means you have to do it one by one, means 1 to 10, but from here I am just selecting a random structure. I have not selected it for final version. I'm just
okay, sir?
showing you how you can check things over there, and how you can mark and label things, label and check the residues in interacting residues. So that point I am saying, for the selection criteria, later on we will be seeing how many interactions they are forming, and how many residues are interacting with that particular structure. So I have not finally selected it. This is just for demonstration of labeling and understanding the interactions. Am I
Okay, sir.
clear?
Okay.
Okay. So here we have labeled our residues of the protein from which the ligand was interacting. If I want to save it, I will directly use save option and provide it address of my file where I want to save. So I will use save save and type the uh, path of the file. So from here I am pose 9h bonds.jpg. So it will look something like this. I have used save d desktop and address of the file I want to save as. Fine. So if I press enter, I should get image saved here. So this file has been saved, but here background is black, and also I am seeing these green lines. So accordingly I can use unselect these green lines. To unselect those green lines, I will use tilde sign and cell like this, so it will unselect everything. You can see it here. To uns Here are few commands like to unselect everything, use this sign, and this first sign is like on your keyboard. If you press shift plus number on the left of keyboard key 1 on your keyboard, so this is that sign. And if you type cell, then it will unselect everything. And to select a model, just use SEL and model space and model ID. Like I was selecting model 3, third model, and third model. And to visualize a model closely, use option use VIEW view and model ID, so it will focus on that model only, selected model. And to visualize everything, means complete protein, just use view, means all the models all the open models will be centered and visualized clearly. Like here, if I have focused on in here, and I want to visualize everything, I will just type this option view, and it will view me everything here. So, and if I want to visualize that particular ligand structure, I will use SEL has 3.9, and that will select that ligand only. You can also see here changes you will be seeing here. And to focus on the selection, I will use view SEL or view ligand number model ID. So like that I can directly focus there. And to save that, I have already told you to use save command. And here if I want to change the background color, I will use this graphics option. Here you can see graphics option, and from graphics option I can use any kind of background there. Fine. Okay, fine. So it is interacting something like this. And we can see that this hydrogen bond is formed between different receptors. So here first this, if I hover over this atom, I can see that it should be hydrogen atom. And now here I am seeing proline, sorry, not proline. Okay, so it yes, this is proline 3.4348. What should I do? Actually these are hindering currently to explain things. I will again select this ligand and use select zone option and select everything nearby. Now I am selecting this particular current things. And now I want to hide everything else. So for that I will do select dash select to invert selection, or indirectly you can use select or invert option here. So for invert selection means to select unselected, leaving the selected thing back, I will use this option select and invert select. So it will unselect everything else, and from here we can use hide option, or alternatively we can type this kind of command, means hide selected. And if we want to hide atoms, cartoon or surfaces, we need to perform 2 to 3 operations. So I have hidden all other things so that we can clearly visualize these interactions. So from here, and also I want to unselect everything for now. So here we are seeing that this one hydrogen bond is formed between this proline structure. So currently this is ribbon visualization, so I will select this proline and use atoms display, so like that it is displaying atoms here. Fine. Actually this deduction of hydrogen bond is due to reason that it has taken all the coordinates of this receptor, and checked that this hydrogen bond and some electronegative atom present in this proline residue is is uh, accepting this hydrogen bond. So if we can we know that there are carbon COH bond and presence of nitrogen in amide peptide structure, so that bond should be forming between like that. So I will try to make it I should hide it. Okay, so this okay, so this is oxygen atom here, and this hydrogen atom in the ligand is bound to some nitrogen maybe. Yeah, this is nitrogen atom, this is hydrogen atom, and this is oxygen atom, and here we are seeing the hydrogen bond formed. So and I want to label it. So maybe I can label it the label distances. If I want to check the distance between two labels, I can use tools. I guess I told you people last time, right? I forgot it. Anyone remember this thing?
No sir, distance measurement I think I don't so clear आपने करवाया था.
I guess I did.
It's a distance
No, sir,
rule.
you haven't taught us.
Yeah,
Okay,
tape.
okay,
Actually, the tape is the one you told.
okay,
Like we
okay.
can.
So we can use this medical image option just for temporary purpose, because all these things I will be telling how those things can be displayed easily. So this is means temporary solution. So from here I have used this medical image option and use this tape option, and it has shown me I am using right click here to draw this distance, to draw something like this. So it is giving me 2.330. So it is taking some roughly uh, taking range of 2 to 3.5 to draw this hydrogen bond. Okay, so like that I have just shown you demo to understand how these hydrogen bonds are formed between a residue and your ligand, or means there might be other cases where protein protein interactions might be happening. So this hydrogen bond is formed like that. If the other interactions will be also based on the distance criteria and type of atoms involved. So also we can note down these note down these residue interactions. Like here we can see that there are involvement of three residues, sorry, two residues, like one is here, this proline, proline 348 with the ligand. This proline is this residue, and this proline 348 is this residue which is forming hydrogen bond this with this ligand. And the second hydrogen interaction is uh, with this arginine residue. So this arginine 369 9 is interacting with ligand, and this proline 348 is also interacting with the ligand. So these two hydrogen bonds are formed, and here we are seeing two dashes. And as I told you that the reduction of the means hydrogen bond is solely based on the cutoff criteria and the involvement of atoms. So what it does, it calculates, it first finds the electronegative atoms, hydrogen atoms, and electronegative atoms. So it will pair one by one. So found it has found two pairs, means this hydrogen bond is bonding with this, so it predicted this, told us about this hydrogen bond. Later on, while looping or cycling through the list, it has also found this. So it is telling us two hydrogen bonds, but at a time it might be forming only single hydrogen bond. So like that we need to understand every interactions. And so this hydrogen bond is okay for now. Later on, if we want to list out all the interactions of the hydrogen bond with a particular residue, or all the residues, so what we can do here, we need to use some command, means so that we can easily visualize our desired things. Like I was not able to plot the distance here, that distance number here. To do that thing, we can directly go to tool option and use interaction analysis. So structure analysis, and here we will be finding hydrogen bonds. And here we are seeing that the criteria I told you that about distance tolerance. So it is tolerating some 0.4 Armstrong distance to draw the to find out the hydrogen bond, and some angle tolerance, because there might be there should be some constant angle for deducing hydrogen bonds, so that we can also set here. But these things are by default, so we should not change now, but over the time you might need these things. So also here is file option. So whatever you are seeing in the log panel, you can list that down in your file for reporting purpose. So I'm clicking apply option, and it should give me some file option, desktop, not desktop, mdt. Okay, so docking analysis, hydrogen bond. So like that it will be saving my all the hydrogen bonds here. uh, uh, sorry, it has calculated all the hydrogen bonds, means within the protein and within the ligand as well. So we need to further refine these things as well. Means selected atoms, click one and selected exactly one and okay. So here we will be limit the selection between the ligand and the receptor structure. So for that we need to first select ligand by using cell has 3.9. So it calculates, it selects the ligand only. Here our ligand is selected at this point, and we want to limit our selection to receptor only, and receptor is at id 2. So I will put has 2, so that it calculates the hydrogen bonds between receptor and ligand 3.9 only. So I am doing two things. First I am selecting ligand only, 3.9 here, and then I am selecting this limit selection option, and restricting the hydrogen bond calculation between selection and atom specification. Means first it has selected ligand, and then I am specifying it to select receptor only. So like that it will select receptor at has 2 here, and select ligand at 3.9, and calculate hydrogen bonds between them, and also using this file option, so that it gives me a file with the ligand with the hydrogen interactions. So I will apply this, and here I should get hydrogen bonds, and I will type save. So it has done. It is actually, you need to have patience, because it will be performing some calculations and take time. So now it has calculated hydrogen bond for me. Okay, I have not saved it as .txt file, so I am seeing no extension for it. I should have named it .txt. Now I will open it in notepad, and here I will be seeing the number of hydrogen bonds it has formed. So earlier we were seeing that there are three hydrogen bonds, means when we have used the view docx, and now here we are seeing one hydrogen bond, means it has reported only one hydrogen bond. So this difference is only due to this cutoff criteria and bond angle relaxation. So tools, so these two parameters are different for view docx and our view docx and direct analysis. So to so to differentiate between those two, we need to understand how these two things work. First, here it has told us that it has relaxed the constraint by 0.4 Armstrong, means the distance tolerance was that, but it has restricted the angle without means it has not relaxed the angle formation. Means like now we already know, if this is a donor and this is the acceptor, and hydrogen is present here, then if this hydrogen bond is formed, there will be some angle. So it has not given any relaxation with for this angle, because this angle might be varying, but it has relaxed the distance of 4 Armstrong for the hydrogen bond formation. So maybe, so that should be the interaction distance between these two atoms, and also the hydrogen, and interacting another atom with which it is going to be donated. So here we can see that in the ligand out.pdbqt file, it is seeing, it has given us the interacting residues. So here is the donor, and donor is at in this file with this id. We have already selected 3.9 structure, and the residue name is ligand, and their residue number is 1, and this nitrogen had donated the hydrogen atom, and donate to the means the other structure was in the receptor.pdb file, and it has id of 2 and chain 1 and proline residue at 348, and acceptor was oxygen atom. So these two information are about receptor and donor. This whole information is about the donor, and this information is about receptor, and last is the atom which is accepting or donating the structure. So similarly this is also the hydrogen information about the hydrogen which is being donated. So this is kind of address of the hydrogen which is being transacted here, and here are the distances, means these 3.225 and two distances are given, and so this distance is between donor and acceptor, and this distance is between hydrogen sorry hydrogen and acceptor. So if we consider this as here nitrogen, hydrogen, and oxygen of the, so let's consider that this is oxygen from proline and this is nitrogen from ligand out. So this distance is between nitrogen and oxygen 3.25, and this distance 2.3 is between hydrogen and oxygen. So like that all the interactions have some characteristics and criteria. You need to understand all of them, and if so this hydrogen bond analysis is will be similar for all the interactions, and also the approach we followed for hydrogen bond analysis will be also for salt bridges, contacts, and other types of interactions. Like if here we have seen that in structural analysis we have been seeing salt bridges, uh, salt bridges. We can also check salt bridges from here, and actually these salt bridges uh, and contacts will be covered in the next session. So I will be dealing more on it.
So,
Yes.
sir, like you were doing when you are like doing hydrogen bonding between ligand, and you have three hydrogen bonding, I think so. And
No, no,
after
no.
that, you are doing two hydrogen bond between receptor and the ligand.
Listen to me. In the first attempt when I was performing using view docx H bond, then there were three hydrogen bonds. Fine.
And three hydrogen bond in between ligand only, na, I think.
Direct. Uh, these hydrogen bonds, both the times I was calculating hydrogen bond between protein, means receptor, and ligand 3.9, ninth pose. Okay, so first time we have got three hydrogen bonds, and second time we have got only one hydrogen bond. So the reason of this is that I have told you that restriction criteria and relaxation criteria. So that distance tolerance and angle tolerance has given this different output, and ViewDocsX is like a built-in third party tool, so it has criteria relaxing than this hydrogen bond option present within the chimera x. So that docx option is given by some third party plugin or third party person. I will be sharing how these H bond criteria can be relaxed to understand how more possible hydrogen bonds could be formed. Like here we have seen three hydrogen bonds were forming, but when we directly use the command, or we will be next time I will be sharing hb command directly, so there we can change the criteria. Okay, let me show you here. If I type hb hydrogen bond, h bonds, So it will calculate all the hydrogen bonds directly here. 475 hydrogen bonds means within the protein, within the ligand and inter ligand protein H bonds it has calculated. So from here we have all the options, and here we will be seeing distance of the hydrogen bond. Okay, so this is the paper in they have listed how they are calculating the distance and angle cutoff for hydrogen bond determination. So this is for the chimera X, and the view doc X option which we were using to directly see the vena option had bit different criteria. So here we can change the distance as well. Radius, dash is name, intermodal, intramodal, relax. Okay, so here this is the relax option. So this is just changing the changing if we should relax the hydrogen bond criteria, then the research paper they are considering. And this is distance tolerance, which they have already by default having 0.4, and also they are also uh, having distance relaxation by 20 Armstrong. So by default these two options are true, but when we were using the second approach, we didn't uh, add 20 Armstrong, sorry, 20 degree of the relaxation distance. So that gave us different results. And while performing view docx and this H bond means from the toolbar, both of the options will yield result here. Like here if we see this option, I'm noting it down here. Okay, I will take new file, this option, and I will also go for view docx. Here I'm directly click on add H bonds, so it will be adding H bond for us. It has done that for us, and I'm copying it this command as well, and check here. So it is showing dash s3. These are means decoration option. Here it is giving us zero tolerance for angle, but by default there are 20 Armstrong, so it is not considering that thing. Okay, so this angle currently here angle criteria is playing main role for the difference in the count. So like that you will be finding different hydrogen bond interactions in other software as well, but the basic concept of angle, distance and involvement of atoms is same for all the softwares, just that they are changing or customizing the uh, uh, determination criteria for hydrogen bond. I hope this point is clear to you all, right?
Like you are setting some criteria
Yes,
on the basis of that you like we are getting different hydrogen bonding like
different
two or
results.
three.
Yeah, you will get different results means if you analyze same result with same docking result with some other software, you will be finding a less or more number of results for that. Means Autodoc Vina has given you this energy minus 5.5876. Some other software might give you some different energy, like that might calculate energy involving or removing some atoms, so that energy might vary for other software as well. So like that it is specific to software and specific to your approach. But the basic concept of means basic experiment which are already established, they are not going to change. Just criteria and the preference will be changing here for from software to software. Okay, so based on these two options, means like hydrogen bonds and involvement of residues, we can determine how we can select different poses. So based on the score, we first preference should be based on score, because if two structures, if out of 9 or 10 structures we have got, best score is predicted based on the energy criteria. So if we select best score, the best score, that is also okay but we should also consider other things as well, like how many interactions there are present. Sometimes what happens, if two two molecules are interacting, so like if one molecule is this, suppose this is our receptor, fine, and here some ligand has given us pose 1, and second pose is here, but this interaction, this here one hydrogen bond is formed, but here no such interactions are happening, but but one more thing is there, that this area, this area or this site is located. Okay, let me restart. Okay, let us suppose that this is surf this receptor is on plasma membrane, fine, and so this receptor is embedded something like this. I will redraw it, sorry. Suppose this is plasma membrane, and our receptor is embedded like this, fine. So if we in vitro model or in real life, some ligand is going to interact with this. So if it is interacting somewhere here, and but in our docking results it is interacting within this region and giving us a score of about 7, sorry, -7, and in here if it is giving us a score of -5. So like that, if this plasma membrane and this receptor interaction will not let that ligand molecule to come here, and here, but here score is higher, and secondly here score is lower, so we cannot select this. We can't propose that this embedded structure ligand is going to bind inside within the plasma membrane, because there should be some different criteria, like we have to justify it through in vitro experiments, that this particular ligand is going to bind inside that uh, within the plasma membrane, but that may not be possible. So for that we may not select this higher energy pose over this one, because this is exposed one, and there are more possibility of this interaction than this, because in the docking part we are not considering this plasma membrane, so we are not considering these hindrances. So like that, we need to prefer for the logical approaches, means the location, position, and already bound parts of the our receptor. So similarly, if we have some multimer protein, and that is forming some complex and forming coordinate or other types of interactions with other units, and it has some only few exposed sites, few exposed part. So in that case we also need to consider those exposed parts, or how those things could be possible if ligand is for interacting it ligand is going to interact at particular site. So we need to consider all the hindrances or other interactions with the protein to finalize the selection of the ligand or new drug which we are going to propose as a potential inhibitor or as a agonist to a drug. So here we are going to use score option, and then hydrogen bonds, then, and also you should know that if there is no the protein is hydrophobic, or a ligand is hydrophobic, or there is no presence of electronegative atom in the ligand, so there will be no formation of hydrogen bond. So this is just a first approach for now. And then later on we will be calculating contact, salt bridges, pi interaction, and other interactions to determine if we our selection is good, or if which selection is good for the docking results. So also these things form the basis of comparison, means if there are multiple drugs we are testing, so for drug 1 and drug 2 we will be seeing how these two drugs are interacting with the receptor, and based on these criteria how these two drugs are performing better. So we have covered these two things today. And next there is an assignment for you all. Assignment is in two parts. First part is 7a, which is like replicate the procedure of docking performed in the research paper. Means, okay, so they might be performing some docking interaction between two, one ligand, one receptor and ligand. So you have just to perform the docking using the same ligand and receptor. And from there, like I have shown you how you can note down note down the interacting residues. Like in here you were seeing, I have demonstrated two methods, using add hydrogen bonds, and also from the toolbar where you have seen in one file you have seen one interacting residue, and in another approach which we were visualizing, there were two interacting residues. So you can note them down and make a table for that, because in the research paper we have to mention all those things. And next, you have to, I have demonstrated only one random residue, 9 number, and so you can select any 5 poses for your comments. So this is like you will be performing docking, opening structure in opening structure in Chimera X, and use view doc X, or or use your on option, switching on off, and then calculate H bonds and note down residues. So this is means your first objective of the of the assignment. And like that you have to do for five uh, five proposed poses conformers which you get for after Wiener docking. Next, comment on difference between docking results with and without Coleman charges. Okay, so last time you have already performed the docking, and there we were doing multiple things. So in one of those approach, from those approaches, or from there, one step was to add Coleman charges and Geistinger charges. So I just want you to perform a docking to prepare receptor with or without Coleman charges and see the differences. And the second option means this is with or without Coleman charges, and the second option, you need to take a receptor from PDB where it will be having natural ligand, means ligand already bound in the PDB structure, and you have to select some antagonist. You can also take a reference of some research paper. Then you will be having single receptor and two ligands, and you have to dock these two ligands and compare their results. So like that you have too much work, but I expect you to do this to have a basic understanding, and I will be understanding how if you are able to understand docking or not. And I will be miss after this contact and other calculation, I will be taking one day class, is 1 hour, to conclude from 0 to this complete docking procedure. So your confusions will be uh, your confusions will be solved, and you will be having a basic understanding of the docking part only. So later on I will be starting with molecular dynamics, and basic part you have already done, like cleaning the protein and all those things. So you will be having added advantage of learning molecular dynamics. easily. Okay, so is there any question from anyone? Is there any question from anyone?
Sir,
Yes.
sir, like you are doing on the primary Chimera X now, sir.
Yes.
I have Chimera only, so please share the video for Chimera so that I can do the sequence or the steps through which we can like I can understand how to select that HB bond and HB bond
Okay, so
docs. Okay, sir.
okay, there will be no view docx, but you will be having some option. I will share that option with you, means within 1 or 2 hours.
Okay, sir. Otherwise, sir, I can't like I how can I then I do that the whole procedure?
If you don't have other options, like sometimes you will be getting zero hydrogen bond, zero contact, zero other options, then one thing is remaining with you, that is score. So you can use that option, means we have other, if we have other criteria, we need to consider them. If we don't, then we need to select the whichever is available with us. So that is the final option, but we need to consider other things if possible. So I will be sharing, and you will be able to analyze the results
Okay,
within the
sir.
time.
One thing more. Sir, when I was visualizing my result, I'm not able to understand. Like my drug was like binding at the two corners. Can I
Okay.
share that, sir?
Yes, sure, please share.
See this, sir. My I have a drug of streptozocine. So my
Okay.
drug is bind in the top corner and the bottom corner only.
Okay, so you have 10 to 8 poses, right? 8 to 10
Yes,
poses.
sir.
So you need
Yes,
to
sir.
check one by one, na?
Sir, that is how can I do that?
What is this? This is RNA or what?
This is DNA only. This is quadruplex is the part of a small part of a DNA. Quadruplex
Okay,
four.
so that simply means you can't dock. You should not dock your drug on the edges, I guess, because the DNA is not freely available like this. Means its edges are not freely available. So if your drug is docking, then these results are not in your favor. You should find some other site like within the double helix.
Okay.
Okay, but you can analyze this thing by selecting one by one. I will share like how you can do this.
Okay,
So
sir. No issues.
any
Okay.
other any other question from this?
No, no, sir. And the other thing, like it is clear to me, and the my result was this only. I'm showing it to you. So this was the result, as well as one thing. This this one. This was last time last day
Output,
we were
okay.
doing.
Yes. So you were able to record these results, and you have got a score.
Yes, sir. Yes, sir.
Okay. But
Okay, sir. You will.
one second. Can you reopen the file?
Yes, sir. Sure,
Okay.
sir.
So if you seeing the upper bound and lower bound RMSD, means I'm just considering lower bound energy, lower bound RMSD. So if you
Hmm.
see that from here we can check that uh, that 3130, 3131. So all those poses like 3, 5, 6, 7 are at same position. Okay, and
Yes, sir.
0 7 4 4 3 are on some different side. So these are like your results are aggregated at one end and other end, as you see in your result. So this RMSD value can help you understand where your ligands are being docked. Okay.
Yes, sir.
Okay, fine. So okay, Madhulika, Basu, I will share you share means how you can perform the docking part in docking analysis in Chimera only. So next is Madhulika, you your question.
Sir, my question was regarding the assignment.
Hmm.
Uh, Whatever you have told about the 7D assignment,
Hmm.
the antagonist should be the ligand.
Actually, here we are
Uh,
performing molecular docking. Am I not audible?
hmm.
Okay, here we are
Yes,
performing
sir, you're audible.
docking with protein and receptor. Sorry, protein and ligand or small molecule. So I would suggest you to choose protein, RNA, DNA, and dock it with ligand or small molecule, because if you are doing per protein docking, this software is going to it will not be helpful, and for that we need to select some different software. So for this assignment, I would suggest you to check go for drug only. Am I clear to you?
Okay, sir.
Okay, so
No, sir, can you please repeat once again?
okay, so you are taking some receptor from the PDB protein data bank. You will clear everything and extract natural ligand, means already bound ligand. Fine. So
Okay.
and bound ligand, so you will be having a receptor PDBQT and leak PDB,
Yes.
rest.pdb, where only protein amino acids will be there, and the extracted ligand, apart from other than water and other elements recorded while doing x-ray crystallography or NMR. So that will be forming your lick PDB. So this one will be your natural ligand, and you will be perform docking these two and get the results. Later on, you just select
Yes, sir.
this receptor and find some
Okay.
similar molecule like this, some similar molecule which you will be using as lig2 or lig ligand antagonist dot pdb, and docking these two receptor and pdbqt and getting some results. So like that you have to compare the interactions between those two.
Okay, okay, all right, sir.
You
No,
got,
sir.
I guess.
There will be two command.
There will be two dockings, means first you are performing docking between receptor ligand, which uh, receptor
The
and ligand,
receptor should be the same, the ligand would
receptor
be
should be
different.
same, and that ligand will be coming from the receptor from the pdb which you have downloaded from the protein data bank, and it might be having some already existing ligand. So that will be means giving you original docking result, and later on you will be selecting another molecule from drug bank or other website that will be giving you another docking result. So based on these results you will be able to compare how this new drug is going to interact with the receptor in comparison to already existing ligand. So like that we find out some antagonist or per new drug or effect of a drug over the existing drug.
Sir,
Okay, sir.
my question is, like when we will do docking, like when we are doing commanding dash ligand name and then the receptor name and then the config dot text.
Yes.
So two different command will be
No,
there.
first the receptor name, na?
Yeah, that order can be changed. Okay, so here this let me clear it to you. This will form one docking, this will form another docking. Okay, so for that means you will be performing vena, receptor ligand, config, and your result one. Fine. So
Yes, sir.
this will go
Yes, sir.
for first time, and then this will be separate and will be done similar like this. Here you will be doing vena, same
Receptor.
receptor ligand to config will be same and result
Yes, sir.
2. So like that you will
Yes,
be
sir.
getting two results, and both the results you will be comparing side by side.
Okay, that's it, sir. Okay, fine, sir.
Madhulika, is it clear to you?
Yes, sir.
Okay, fine. So any other question from anyone else?
Uh, uh, Sir, hello.
Yes, Sanjay.
Sir, actually, I have a doubt that you told that informational structure will be selected based on the like certain criteria are there, like hydrogen bond scoring, like this you have told me.
Yes.
In that, while we are preparing both receptor as well as ligand, we used to add hydrogen bond. You already said that since these structures are being developed with the X-ray diffraction method, so the hydrogen bond won't be like picked up,
Available, yes.
so that we have to add like that you have said.
Yes.
So the doubt is like if I add hydrogen along only for receptor, not to ligand, what will happen? It will either it will affect the result or not.
Actually, the approach is to not add hydrogen to the ligand, because
Okay.
if we understand clearly, if there are two electronegative atoms and both have the
Yeah.
hydrogen, they won't
Yeah. Yeah.
exchange the hydrogen, so we don't
Hmm.
actually add hydrogen to the ligand, and in
Ligand.
fact we
Okay.
remove the hydrogen from the ligand, so that one is act as a receptor or donor, and so that pair is not affected. You can also test it
Okay.
you can also check it through using docking, so that what is the effect of the difference. Like that, I have already given you one assignment to understand how Coleman charges are going to affect.
Yeah, yeah, yeah.
Okay, so
Okay.
like that you can perform your own and develop your own understanding. Actually, that will be better approach, because you will be dealing with different molecules and different structures, and you need to find out your own ways, because during analysis you will be dealing with, like, there might be some different compartments, like you might be dealing with the protein which are at different pH, like in lysosomes or
Okay.
other places, so you might be dealing with them, but I am sharing all the resources, like at pH 7, so there will be different cases, and you need to have different approaches for dealing with those situations. So these basic experiments or new assignments are for that purpose, that so that you have your own understanding and deal your problems yourself.
Okay. Then another doubt is like while we are seeing how to see the H bonds and how they are created, you have said, no, sir.
Yes.
So in that you said like there are certain criteria like how to say angle bond tolerance, these things you have said.
Yes.
So since how to select that this thing, like this will be a correct thing, how we know that this will be correct, this will be wrong, so that the hydrogen bond, because it affects hydrogen bond formation, no, like if we increase the torsion angle, it might go for 3 bond. If we decrease the torsion angle, it will reduce to 2 or 1. So how we can say this torsion angle for this thing it is correct, like
Okay,
it will
so
be.
the basic idea behind the hydrogen bond is from the research paper, or means already established experiments,
Okay.
like they have calculated all the hydrogens, and the range of hydrogen angles they might be, means what is the constraint for the hydrogen bond formation. There are already experiments, and there are values already noted down, fine, and also the
Okay.
distance, so that forms the base for that. But here in the
Okay.
experiment, during the docking, uh, receptor is rigid, but ligand is rotating, fine.
Yeah,
So
flexible. Yeah.
yeah, flexible. So due to that flexibility, there might be cases where the docking program might not be able to complete that part, means to correctly rotate or conform the ligand. So if we perform that relaxation, if we add that relaxation from the base, then there are chances that we might find possible interactions.
Oh, you are saying that the flexibility of the like that ligand will be we will take the base of any research paper so that we will assign certain values so that this flexibility can be changed, like you are saying.
Yes,
That
not any research paper. The like already in
just a
chemistry.
basic.
Yeah, already in the
Okay.
chemistry they are already
Yeah,
published.
yeah, yeah.
Okay, so I will
Correct.
suggest you to go through. I have open Camera X. There is one paper. I don't know if I have noted it down. I'm sharing it again. Here is the one research paper. If you are able to see my screen,
Yeah, you showed us
yes. So
that
I will suggest you to go
method
through
and
this.
geometric centric
This
criteria.
this is one paper, and there is one more paper which had deduced the distance of the hydrogen bonds and angles between different atoms in hydrogen bond formation. So I would suggest you to go through that, so that while you are doing your OR analysis, you can select these criteria. Also, these criteria in a software are like their best experiences because most of the people use software without changing the parameters. So these are
Yeah.
means best setup, but you might be needing those to change.
Okay.
So I guess you should go through the research paper for this point, because if you are altering these basic set things, you need to use these changes in your research paper. Otherwise, you need if you are mentioning that I am using Chimera X to find the hydrogen bonds, then the understanding is that you are using default options, and those default options are these, means they are
Okay.
tolerating
Okay.
0.5 0.4 and using this relaxation. So this is the basic understanding. If you are reporting a software name, you if you are citing a software name, or if you are
Okay.
making any alterations, then you need to
Mention that.
cite original research paper, or you need to justify your changes, why you are doing that.
Okay. Okay. Okay.
So I guess this part is clear to you,
Yeah.
right?
Yeah. It's clear. It's clear.
Okay, so similarly we will be using contacts and other interactions, and for that similar logic will be applied.
Okay.
Is there anyone else? Okay, so we will be connecting later tomorrow, next week. Good day, good night.